good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Lubinda with another video. Alright, so in this video we are now continuing on the examples and the chain rule. Now we are going to look at some practice questions. So we looked at 4 example questions and that made us 4 example videos. Now in this video we are going to answer question 1, the next video question 2, then another video question 3. So in these videos we're going to be using the chain rule. What we have learned from the chain rule, we're going to apply it here. Okay, let's get on with the video. So we have this question which is saying differentiate with WRT, meaning with respect to x, 3 minus x minus 2x squared raised to the power 5, x squared minus x plus 1 raised to the power 3, ax plus b to the power n, and then d is 2x minus 1 divided by 2x. Everything is being raised to the power 3. So let's start with a. So for our a, we have 3 minus x minus 2x squared. All of that is being raised to the power 5. So we will say y is equal to 3 minus x minus 2x squared. Everything being raised to the power 5. Okay, so for question A, we're going to use both the two methods that we have learned. That is the chain rule and the one that involves the core. So I'm going to start with the chain rule. I'm going to leave my answer right here so that we can compare. Okay? The chain rule says you let u be equal to whatever is inside here in the parentheses or the brackets, which is 3 minus x minus 2x squared. Okay, so that would become your u. And then what remains is y is equal to, so I'm just saying y is equal to this whole base. Okay, everything here has been substituted by u. So it is u, but it's being raised to the power 5. U to the power 5. And then now we have two functions, two combined functions. We differentiate this one and then we differentiate this one. We differentiate u with respect to x, we differentiate y with respect to u. So this would be du dx is equal to the derivative of the constant is 0. Here we just get the number in front of the variable. I'm just simply saying that if you can see there is no power here that you can see with your eyes, but there's a power 1. So if there's a power 1 on a variable, just get the number in front of the variable, which is the coefficient. So the derivative of this is negative 1. Then here I'm going to have negative 4. Then the x, we maintain the base, which is the x, we lose 1. So power 1, we just write it like that. And then this side, your dy, du will be equal to 5u to the power 4. Then your chain rule says dy dx is equal to dy du multiplied by du dx. So your dy du is your 5u to the power 4 multiplied by your du dx is a minus 1 minus 4x in that order. And then to proceed, we'll just clean up everything above. Okay, so this is 5u raised to the power 4. Hopefully you can see that. And then there's a stage where we said let u be equal to whatever is inside this bracket. This bracket, that's what we said, okay? So what we have remained with is 5u to the power 4. Okay, 5 times u to the power 4 times negative 1 minus 4x. So we are saying that our dy dx is equal to 5. U is whatever is inside the brackets, which is 3 minus x minus 2x squared raised to the power 4. And then this multiplication symbol, we'll just leave it out and write our final answer like this. And this is your final answer. So 5 multiplied by 3 minus x minus 2x squared raised to the power 4, then multiplied by negative 1 minus 4x. So we can say that our dy the x is equal to 5 multiplied by 3 minus x minus 2x squared raised to the power of 4, then negative 1 minus 4x. So this is your answer for question A. Okay. Due to the length of videos, I'm going to end it here. I'm going to answer using the other method, and then I'll end the video there, alright? Because if the videos are long, people will not have the attention span to actually understand what is happening. Okay, so this is the question right there. Y is equal to 3 minus x minus 2x squared raised to the power 5. Everything is being raised to the power 5. So to differentiate this, we'll differentiate the entire function the way it's looking like that. So you will say that your dy dx is equal to 5 multiplied by this entire function. So 5 multiplied by the number in front of the bracket, but here there's an invisible 1. So 5 multiplied by that invisible 1 to simply 5 multiplied by 3 minus x minus 2x squared. And then here there's a power 5. The power 5 will lose 1, it will become power 4. And then you multiply by the derivative of the core. So what have I done? I've differentiated this function the way it's looking. Okay? The way this function is looking, I've just differentiated it. It's like I'm saying this entire thing is x. The way you differentiate x, okay? You get the number, the power there, the exponent, you multiply by the number in front of x. Now in this case it's the number in front of the brackets, which in this case was 1. So I just got the 5. The x remains unchanged, or the core remains unchanged, and then you have to lose 1. Okay, so the power will lose 1, it becomes power 4. You multiply by the derivative of 3 is 0. Derivative of negative x will just be negative 1. The derivative of negative 2x squared is minus 4x. Okay, minus 4x. So you therefore your dy dx would be equal to 5 multiplied by 3 minus x minus 2x squared multiplied by 1 minus 4x. And if you, of course this is being raised to the power 4. And if you compare this answer to the answer we found right here, these answers are the same, which shows that you can use either one of the methods, either one of the two methods, whichever you are comfortable with. This marks the end of this video. I would sincerely like to thank you for the support. This has been Cornelius with another video, and bye bye.